So in this particular question, we have a function given by sine 3x over x. So we need to determine the nature of this particular function at the origin. Or we can say when x tends to 0, what is the value of this particular function going to be? So when we do a direct substitution here, so we see that the given function is giving us an indeterminate value at the origin. So what we have to do is we're going to use the squeeze theorem in order to find the value of this function, the limiting value. So we are going to use the definition that the limit of theta going to 0, if we have sine theta over theta, this is equals to 1. So let's use this definition here. So we have limit x going to 0. So we have sine 3x, the theta here is 3x over x. However, we need a 3x over here. So let's divide by 3x, and since this is an extra term, we are going to multiply it by 3x divided by the term which was the denominator which was already present, that is x. So this gives us limit x going to 0 sine 3x over 3x. So we have x and x cancelling out, that leaves us with 3. So that 3 being a constant can be brought in front of the limit, and this value, the limit x going to 0 sine 3x over 3x, is going to be 1 using our definition. So we have 3 times 1, which is equals to 3. So that means the limiting value of the given function sine 3x over x when x tends to 0 is going to be equals to 3. So here we have another function which is sine 5x over 2x, and we need to determine its limiting value when x tends to 0. So let us do a little bit of manipulation here. So we have limit x going to 0. We have sine 5x. So that means the angle is 5x. So let us divide by 5x. And when we are dividing by 5x, so we have to take care of it. So we're multiplying by 5x as well, divided by the denominator, which is twice of x. So twice of the x and x gets cancelled out, leaving us with 5 over 2. So that can be brought in front of the limit. So we have 5 over 2, limit x going to 0. We have sine 5x over 5x. So this is the definition, which will be equals to 1. So we have 5 over 2 times 1, and therefore the limiting value of the given function when x tends to 0 is going to be 5 over 2. So here we have the function sine ax over sine bx. So we need to determine its limiting value when x tends to 0. So let us do some changes to our given function. So we have limit x going to 0. So we have sine of theta. So theta here is a of x. So let us divide by a of x times. So since we are dividing by ax, we need to multiply by ax as well. And we have sine bx in the denominator. So bx is the angle of sine. So we are going to divide, multiply by bx. So this, bx being an extra term, we're going to divide by bx as well. Now what we have is limit x going to 0. Now x and x gets cancelled out, so this is a constant term a over b, so we can bring it to the front of our limit. So we'll limit x going to 0 sine ax over ax times, and we are going to apply our limit to the second function, which is bx over sine bx. Now our definition states that limit theta going to 0, we have sine theta over theta is equals to 1. However, this is also equals to limit theta going to 0, we have theta over sine theta. So when we use this definition, that gives us a over b times 1 times 1. So we have a over b. So this is going to be the limiting value of the given function when x tends to 0. So here we have a function given by sine squared ax over sine squared bx, and we need to find its limiting value when x tends to 0. Clearly this is similar to the previous problem while we have a squared term in both the numerator and the denominator. So that can be rewritten as limit x going to 0. So we have sine ax whole squared times 1 over sine bx whole squared. This will be rewritten as limit x going to 0. So we have sine ax squared. So that means we have 2 sine ax, that means they are in product. So we are going to divide it by ax whole squared. So dividing by ax whole squared means we also have to multiply it by a squared x squared times. So we have sine bx whole squared in the denominator. Now we're going to multiply it by bx whole squared and divide it by b squared x squared. Now we can get rid of the x squared term from both the numerator and the denominator, and we can evaluate the limits. So our limit will be, so a squared over b squared being a constant, we write it in front of the limit. So we have limit x tending to 0 sine ax over ax whole squared times limit x going to 0 bx over sine bx whole square. Now clearly the limit will be equals to 1. The reason being, so here we have sine ax over ax squared. So that means it can be written as a product of sine ax over ax with itself. Now when we evaluate the limit for both the two functions, so each of them are going to give us 1. So indirectly we are saying that the sine ax, so that's let me rewrite it, let me specify what I'm trying to say, that for limit theta going to 0, we know the sine x over sine theta. So we have sine theta over theta is equals to 1. Similarly, we can say that if we raise the function to some positive integer n, then this also holds. So this is also going to be true. So n can be, in fact, actually n can be any integer value. So this is also going to be equals to 1. So that gives us a squared over b squared times 1, and the second limit is also going to be 1. So this is going to be the limiting value for the given function when x tends to 0. So here we have the function given by sine squared 3x over x squared, and we need to determine the limiting value when x tends to 0. So let us rewrite the given function. So we have limit x approaching 0. So sine squared 3x can be written as sine 3x whole squared. So that means we need to divide by thrice x whole squared and need to multiply it by thrice x whole squared as well. So that will give us 9x squared. And we already have the x squared term in the denominator. So that can be used to cancel out x squared from both the numerator and the denominator. So leaving us with the constant 9. So that constant 9 can be brought in front of the limit. So we have 9 times the limit x tending to 0. So we have sine 3x whole squared, or we can rewrite it as sine 3x over 3x whole squared, and this value, this limiting value is going to be 1. So we have 9. So the limit of the given function when x tends to 0 is going to be equals to 9. So we need to determine the limiting value of the function sine 3x over 5x when x tends to 0. So let's rewrite the given function. So we have limit x going to 0, we have sine 3x, so we're going to divide sine 3x by 3x, and we're going to multiply it by 3x as well. Then we have 5x in the denominator, so the x and x gets cancelled out, leaving us with 3 over 5, which can be written in front of the limit. So we're 3 over 5 times limit x tending to 0 sine 3x over 3x. So using the definition, limiting value of sine 3x over 3x when x tends to 0 is going to be 1. So that gives us 3/5 of 1 as 3/5 times 1, or we can say it's simply 3/5. So here we have a function given by sine 5x over tan 3x. So we have to find its limiting value when x tends to 0. So let us begin by rewriting our given function as limit x going to 0. So we have sine 5x in the numerator. So we're going to divide sine 5x by 5 of x. Now this being an extra term, so we have to multiply it. Similarly, we have tan 3x in the denominator. So we are going to multiply it by 3x, and then 3x being an extra term, we have to divide it by 3x as well. So this is going to take care of the x for both the numerator and the denominator of 5x and over 3x. So now we can rewrite our limits as 5 over 3 limit x tending to 0. We have sine 5x over 5x times limit. So we're going to calculate the second limit on the function 3x over tan 3x, which is equals to 5 over 3. So we have sine 5x over 5x. The limiting value is going to be 1. So here the definition states that for limit theta going to 0, we have tan theta over theta is equals to limit theta going to 0, theta over tan theta is equals to 1. So the limiting value of theta over tan theta when theta tends to 0 is also going to be 1. So we have limit x going to 0, 3x over tan 3x will be equals to 1. So that gives us the limiting value of 5 over 3. So here we have tan 8x over sine 2x. We need to find its limiting value when x tends to 0. So we can rewrite our given function as limit x going to 0. So we have tan 8x over 8x. So this is 8x being an extra term. So we have to multiply it by 8x as well, times 1 over sine 2x. So we have sine 2x in the denominator. So we're going to multiply by 2x and divide by 2x as well. So 8x over 2x is going to give us 8 over 2 times the limit. So we're going to calculate the limit on tan 8x over 8x. So this is going to be our first limit, times we're also going to calculate the limit for 2x over sine 2x. So we have 8 over 2, which is 4, and the two limiting values of the two functions, tan 8x over 8x and 2x over sine 2x, are going to be 1 at x going to 0. So our limiting value is equals to 4. So here we have a function given by tan mx divided by tangent nx, and the limiting value we need to figure it out when x tends to 0. So we will begin by rewriting our given function as, so we have tan mx over mx. So mx being an extra term, so we have to multiply it, and we have tan nx in the denominator. So we're going to multiply it by nx and divide by nx. So mx over nx, the x gets cancelled out, leaving us with m over n, times limit x going to 0. We have tan mx over mx times the limit x going to 0. We have nx over tan x, tan nx. So this limiting value was going to be 1, and the limiting value of tan mx over mx when x tends to 0 is also going to be 1. So that leaves us with m over n. So this is going to be the limiting value of the given function when x tends to 0. So here we have a function sin x times cos x divided by thrice x. So we need to find its limiting value when x tends to 0. So there are two ways of solving this particular question. So let's try the first way, which will be, so I'm trying to do method number 1. So method number 1, so what we're going to do, we're going to rewrite, or we're going to arrange the given function as sine x over x times cosine of x. So 1 over 3 being a constant, so we can write it in front of the limit. So we have 1 over 3 limit x going to 0 sine x over x. So this is going to be our first limit, and we are also going to apply our limit to the cosine function. So we have limit x going to 0 cosine of x. So this is equals to 1 over 3 times 1, and limit x going to 0 cosine of x is 1. So this is, so let me write it down. So we have limit x going to 0 cosine of x, so the value is going to be 1. So this gives us 1 over 3. Now let's do method number 2. So we have limit x tending to 0 sine x times cosine x. So what we're going to do, we're going to multiply by 2 sine x times cosine x, and also we're going to divide by 2. So that will give us 6x. So we have limit x tending to 0. Now this is an identity, 2 sine x times cosine of x, so that gives us sine of 2x. So we have sine of 2x divided by 6 of x. That will be limit x going to 0 sine of 2x. So we need a 2x in the denominator, so we divide by 2x and then multiply by 2x. So we have 2x over 6x, so that gets cancelled out, the common terms, the common factors, leaving us with 1 over 3. So we have 1 over 3 times x going to 0 sine 2x over 2x. Since the limiting value is equals to 1, so this gives us the value 1 over 3. So method 2 is also giving us the same value. So let me write down the identity that was used here. So we used sine 2 theta is equivalent to 2 times the product of sine theta and cosine theta.